morning's video is about 7.4, running a d-test for population proportion. The test statistic for population proportion is p-hat, and we're going to use p-hat to make some conclusions about p. Now, we can only use it if the sample size is big enough, so we do need to check that n times p and n times q is greater than or equal to 5. And our test statistic for this, just like in the confidence intervals, will still be z. So there won't be any of those discussions about which one to use. Z is found by taking your test statistic, taking your sample statistic minus the population divided by the standard deviation. So in our case, that's p-hat minus p, and then divide by p times q divided by n. So just like in the last problem, we need to write down last section, we need to write down everything we know, and make a null alternative hypothesis. If you want society claims that less than 35% of the households own a dog. So I use the word less than, down here equal to, so the proportion is less than 0.35 is the ha. This is the claim in the problem, so I'll write that down. The null has to be the complement, so it will be p is greater than or equal to 0.35. And a random sample of 400 households, 150 of them claim they have a dog. That'll give us what we need to find p-hat at an alpha level of 10%. Is there enough evidence to support the claim? So what else do we still need for our problem? We still need Q, what looks like if you're looking at your to-do list. So here's our p-hat, and Q would be 1 minus p, so Q is 1 minus 0.35, so we're going to need 0.65. And when we did confidence intervals, you only used p-hat, q-hat, because you didn't know anything about p. But it's better to use p and q. Alright, so our choice for statistic is that we will use c, because n times p and n times q are greater than or equal to 5. You can check that if you want. But 35% of 400 is going to be bigger than 5, and 65% of 400 will be bigger than 5. You just need to acknowledge it. Now we're going to find z. We find z by taking p-hat, which I would not round, but if you are going to round, don't round smaller than 4 decimal places. But we need p-hat minus p, and then divide by, we're going to have a giant square root here, 0.35 times 0.65 divided by 400. All of that is in that square root sign. So I'm going to give you a numerator and a denominator so that you can check your math. So there's my numerator and denominator. And my z then will be 1.6773. But since my table only goes to 1.68, it's probably the z that I would pick. Now, again, p-value works the same way. So our p-value statement is going to be the probability that z can be what compared to that 1.68. So if we come back up here in the book, it's supposed to be less than. Well, I'm not even going to finish this problem. I'll tell you why. Where is 1.68 picture-wise? So here's 0, here's 1, and here's 2. So somewhere here, in the direction of the ha is less than. So the answer to this is way more than 50%, and I can see that by shading it. So I would fail to reject my null, because the p-value is way higher than the alpha level. If we fail to reject the null, would we have evidence to accept the claim? So we come back up here. If we're failing to reject the null, that means we're keeping this one. and we're throwing this one out, and it was the claim. So you do not have evidence to support the claim. Alright, let's try another one. Research center claims that more than 80% of females in their 20s are taller than 62 inches. So I hear direction, but I don't hear equal to. So P is greater than 0.8. Means that the HO is less than or equal to 0.8. Our claim again happens to be the HA. A random sample of 150, 20 something, seriously Miss May, females is taken, and 79% are taller than 62 inches. Alpha level is 10%. What is that 79%? That's your P hat. So P hat's 79%. Is there enough evidence to support the claim? So we did a survey. We found 150 people that we randomly selected, and only 79 were taller. Does that still support the claim that it's really greater than 80? So we're going to use Z again because the sample size is big enough. We're going to create Z by taking P hat minus P and dividing by the square root of P times Q over N. If I've done my math right, I'll end up with a negative Z-score of 0.3062. Now, remember, your p-value statement goes in the direction of the HA, so this would be the probability that Z is greater than this value. And again, we have that same situation of, look where this is. I don't need technology to work this problem, I'm smart. Negative 0.3 is somewhere here, and if I want greater than, I'm shading more than half. So the p-value is greater than the alpha level. What does that mean for this problem? Well, it still means we failed to reject the null. Where was the claim? The claim was the HA. So since we failed to reject the null, we also reject the HA, right? And so now we're going to say that no evidence for greater than 80. In the end. The last one should be a two-tailed test for to take a quick look at. Let's see if I can get this done in less than 2 minutes. The Research Center claims that 25% of graduates think college degree is not worth the cost. So P is 0.25. So you either think that it's not worth it or you don't. And so here's our claim. We do a survey, and the survey finds that 21% think it's not worth the cost. We surveyed 200 people, and we're setting the rejection level at 10% again. So again, we use Z because the sample size is big enough. Z is found the same way as it was before. The only thing that's going to be different in this problem is how to do the p-value. So we do our subtraction. We take the square root of P times Q, divide by N, take a look at what size Z is. So Z is negative 1.31 is where I'm going to stop for that one, because we do need our table for this one. P-values, when you're dealing with two-tailed tests, go in the direction of the tail. So the p-value is going to be 2 times the probability that Z is what compared to negative 0.31. So if you draw him, here's 0, here's 1, here's negative 2. Somewhere here, the tail is not on the right side because that's too big. So the tail has to be less than. And so we're looking at what's the probability that Z is less than negative 1.31, and we double that to get our p-value. Now, I don't have a table in front of me, so I did use my calculator to get this number here. you see from my area. So if you're off a decimal place from me, don't worry about it. I used technology to find this, but I need to double that answer, which would bring me up to here. And this is greater than our alpha level, so we fail to reject the null one more time. And the null is the claim. And so, do we have enough evidence to reject the claim? And the answer to that question is no. Okay, I think once you've muddled through 7.2 and 7.3, you're going to find 7.4 a lot easier. But please let me know if you need more examples.